All right, you guys, I want to do a quick little review of factoring because and what factors are. This is an Algebra 1 initial topic for sure, and so Algebra 2 should be review of it, but again, my assumption is we're going to just kind of build it from scratch. And so I'm going to walk you through the stages of kind of developing what it means to be a factor and how we factor and different types of factoring. So hopefully I'll move quickly through the early stages and slow down a little bit at the end, okay? Let's take a look at some problems together. So let's start with a basic idea of the factors of 12. What are the factors of 12? 1 and 12, 2 and 6, 3 and 4. These are the factor groups of 12, right? They all make 12. So what does it mean to be a factor? It means that we're breaking it into two parts that multiply to obtain the original value. Factoring really is dividing, isn't it? Take a look. We had the 12 there, and we divided it by 6 and it gave us 2. We divided it by 4 and it gave us 3. We divided by 12, it gave us 1. So if we're looking at types of, what it means to factor, again, the idea is we're kind of saying, well, if our number is, say, 15, the factors are things that multiply together to obtain that particular answer. So in this case, there aren't very many factors, but these would be known as the factors because together they multiply to obtain that. That should be fairly straightforward. But what is a little more interesting is what happens if I say 6x squared y was the item and not the number 12 or 48. And we say, what are its factors? Now, what are its factors really means how can I divide this into two things that multiply to that? So it might be 6 times x squared y. Together, if you multiply those, you get 6x squared y. So this would be a factor, and this would be a factor. How about another one? Let's try 6x as one of the factors and xy as the other factor. Well, 6x and xy, if you multiply those together, you get 6x squared y. These are factors, and so we get this idea of there's one factor, there's the other factor, because together they multiply to obtain the overall goal of 6x squared y. So let's look at some other cases of what it means to factor. Let me show you another one. So this is a little trickier because it's not just one item. There are two items here. So we would be looking for two things that if you multiplied them together, you would get 4x plus 10. Now this might take a little bit of thought, but if we pulled out, let's say, a 2 as one of the factors and divided it into 4x, you'd have 2x plus 5. Hey, this works nicely because 4x plus 10. So one factor would be 2 and another factor would be 2x plus 5. Those would be two things that if you multiplied them together, you would obtain the goal of, if I multiply this and this, I would obtain 4x plus 10. How about this other one? What might be the factors? I have an x squared and a 4x. Oh, I see. An x, let me just change my pen a little bit. An x would be maybe one of the factors, and the other one would be x plus 4. Do you see how that's starting to work nicely? Let's see. That would be x squared, and then this would be plus 4x. This would be one factor, and this would be one factor. Factoring really is dividing. Do you see how that's what I'm doing? I'm dividing out. In this case here, watch, I'm dividing out the x, and by doing so I found out what the other item is. It's x plus 4. So together they multiplied to obtain that answer. Let's look at just one more of these. All right, so let's take a look. What could we break this into by dividing something out? Oh, I could divide a 3 out because I see kind of an ability to use a 3 here and a 3 here. And I could divide out also an x because I see at least one x in the two groups. So there's one factor. Now when I divide 3x into that binomial, I get the 3 divided by 3 cancels, 3x cubed divided by x leaves me with x squared. 9 divided by 3 is 3, and x divided by x is just itself. And so again, what I noticed is that there was some commonality of the x's that could be taken out, and that's why it was able to come out. So again, what does it mean to factor something? It means to divide out your values. And so I divided out a 3x, and the remainder was this nice little guy right here. So these are known as the two factors of that particular case. You see, we learn a lot by thinking about multiplication. Let's say we had 5x times x plus 3. You know what to do here. We distribute. And so we would get 5x squared plus 15x. So this is called multiplying. Well, the opposite of multiplying is called factoring. So what factoring means is to look at what we can divide into this. The largest thing is what we always pick. I see a 5 because the 5 goes into this item here and into this item here. I also see an x because, again, I see that it works. I can take an x out of each of those groups, and that's the most I can do. And so when I divide 5x into 5x squared, I'm left with an x. When I divide 5x into 15x, I get 3. And guess what I just found? One factor is 5x, the other factor is x plus 3. Factoring is just simply division. It's division, and this is multiplying. The inverse of multiply is to divide, or in other words, to factor.